Hey guys, these notes are for multiplying polynomials. We are in Unit 1. Our essential question is, what is the process we use to multiply polynomials? So in the previous lesson, we learned how to add and subtract polynomials. So we were combining like terms, adding and subtracting those terms together to simplify them and condense them down. We are multiplying today, so it is a little bit of a different mindset, but we still need to know how to combine like terms and all of that, but we are going to be multiplying today. So with distribution, so basically, I'm going to put this in terms that we would typically take. So you take, or you not take. Remember, distribution is the operation of multiplication, right? So you multiply the outside term into all of the terms in the parentheses. Okay, so that's just an example, or not example, our definition, and I'm going to give you an example. So, for example, and we've done distribution quite a bit, but we're just going to go ahead and just put, I'm going to do a number and letter example, and then just an all letter example. So, like 3 times x minus 2, right? Remember, distribution is the operation of multiplication, so it's super important that we multiply and we're not adding. So we would do 3 times x. And I put these arrows for a reason. Don't just write them to write them, right? I put the arrows there to remind me that I'm distributing to every term in those parentheses. Here I have 2 terms. So 3 times x is going to give me 3x, and 3 times negative 2 is going to give me negative 6. Another example we'll do with letters. A parentheses b plus c. Okay, I'm going to do the same thing here. I'm actually going to erase this and make this a little bit neater. Okay, same thing, we're going to distribute and multiply. A times b is going to be ab. A times c is going to be positive ac. So you're just multiplying it to the terms on the inside, however many there may be. So we're going to first do single distribution, and then we'll go into double distribution, and that's going to really take us through the rest of the notes all the way through question 10. So, single distribution. This is when we have a single term on the outside of the parentheses and we want to distribute it in. So this is what we are used to doing. Okay. So let's go ahead and start. We have 5 on the outside of the parentheses, so we have 5 times x, which is going to be 5x. And then 5 times 6 is going to be positive 30. Remember, you are multiplying here, so make sure you're not adding on accident. Okay. So we're going to move on. And again, you can't combine those. They're not like terms, so this would be your final answer. Moving on to number 2, okay, now this one's a little bit different. The term's on the back end of the parentheses, but really you just treat it exactly the same. So you want to distribute it into the terms on the inside. So m to the 5th times 2, okay, actually I'm going to go to the front because it's kind of weird if I do it that way. So let's start at the front here. M to the 5th times 5m. Now remember yesterday we talked about how x times x is x squared. Okay, so basically you have 2 x's being multiplied together. Well, if I have x squared times x, that's going to give me x cubed, and here's why. This means x times x, and this means I have times x. So in total, I have 3 x's together, okay? So here, when we're multiplying this m to the 5 times this m, we're adding in another m. So this would be 5 m to the 6th, because there's an extra m in there that you're multiplying in. And then you're going to multiply it to the 2 as well, because you have that other term. And this would be positive 2m to the 5th. Now these are not like terms, so I cannot combine them. So then this would be my final simplified expression. Remember, we're simplifying these. We cannot solve them. There are no equal signs to solve. All right, moving on to number 3, we have negative 3z times z minus 4. Again, distribution. So we're going to do the same exact thing. Negative 3z times z. Now, if x times x is x squared, z times z is z squared. So this is going to be negative 3z squared. And then we have negative 3z times negative 4, and that's going to give us positive 12z. Okay, so you're going to make sure you're very careful with those negative signs because they can get us really easily. I'm going to be careful with those. Okay, now this one looks a little bit tricky. Now, when you're multiplying stuff like this, you can only multiply things that are like with each other. So you're going to do the same exact thing, you're going to distribute in. Okay, well, here we have the x's are in common. So this is technically x to the 1, right? You're doing x y squared times x to the 5th y. So in total, you have x to the 6th because you have an extra x being multiplied to the 5 x's over here, right? Remember, x to the 5th means you have x times itself 5 times. And then you're adding in that beginning one over here, right? That's the extra x. So in total, you have 6 of them. Okay? And then you're going to do the same thing with the y's. You have 2 y's here, you have a single y here. So if I were to multiply those together, I'd have y cubed, y to the 3rd power. Okay? And then I'm going to do the same thing to, I'm trying to figure out what color to use, sorry. We'll use pink. And then we're going to do the same thing to the second term over here. So this would be positive x to the 7th and y to the 5th. So this is a little bit of a preview of what we're actually doing tomorrow with the exponents. So basically you're kind of like adding them. The exponents are being added. You're still multiplying these terms together, but it looks like they're being added together. So that's how we get that one, right? We have 2 of these y's, and we multiply with 3, we will get 5 in total, right? Because y squared means y times y cubed means y times y times y. So in total, you have 5 y's being multiplied. That's where the y to the 5th comes from. Oops, I didn't mean to erase that whole thing. There we go. And these are definitely not like terms because I have to have the same variable and same exponent. So this would be our final expression. So this is just a review of single distribution. Again, the only new stuff for us would be number 2 and 4. Those are a little bit more trickier because our exponents are like kind of bigger now, so we have to think a little bit more. But process for multiplying is exactly the same. All right, now we're going to do double distribution. So it's similar to single distribution. You just have to do it twice. So for example, right, here I have 2 sets of parentheses. Well, let me ask you something. If this x was not here and there was just a 3 in front of these parentheses, what would you do? You distribute, right? Right, so you distribute that. Well, what if the 3 wasn't there and it was just the x on the outside of the parentheses? You would also distribute, okay? So you're going to actually end up doing both. That's why it's called double distribution. This is super important. You're going to be using this a ton. You use this a ton in geometry, you use this a ton in algebra too. You do need to know how to double distribute. So we're going to start. I always start to distribute with the first term first. And I distribute to however many terms are there on the second parentheses. So in the second parentheses, I have 2 terms. So I want to make sure I multiply it to 2 things. So x times x is going to give me x squared. X times negative 4 is negative 4x. Okay, so I've done one term. I've done my x. Now I have to do the 3. So I've distributed a single time. Now I got to do it that second double time. So 3 times x is going to be positive 3x. Make sure you keep the sign there. And then 3 times negative 4 is going to be negative 12. Now, how do I know this is multiplication? Remember, parentheses means multiplication. If there was a plus sign in between, I would add them, not multiply. So you want to make sure you're paying attention to whether there's a plus sign, a minus sign, or if there aren't any signs and it's just 2 sets of parentheses being multiplied together. Now, we're almost done, but you always want to check for like terms. In this case, I do have like terms. And usually if you do it in this way, they're going to end up either in the middle or they're going to end up on the outside. So we have negative 4x and positive 3x. So those are our like terms. So we would have x squared. And then negative 4x plus 3x is going to give me negative 1x or just negative x. And then negative 12 doesn't have any like terms, so it stays as is. And this would be our simplified expression. So you're typically going to end with a trinomial. You're going to end with 3 terms typically. Not always. Sometimes you end with 2 terms. So you want to combine anything that you can. All right, moving on to number 2. Okay. Whoops. Same thing. You see that you have 2 sets of parentheses. The operation in between is multiplication. So you're going to multiply these binomials together. Now, these are binomials, right? You have 2 terms here, you have 2 terms here, so you're multiplying 2 binomials with each other. We're going to double distribute. Okay, so you're going to take that first term and you're going to distribute that first. So 3x times 2x. Well, 3 times 2 is 6, right? And x times x is x squared. And then you 3x times negative 5, which is negative 15x. Okay, so you've distributed one of the terms, but you're not done yet. You got to double distribute and make sure you do that second term as well. So we have 1 times 2x, which is positive 2x. And then 1 times negative 5, which is negative 5. Before you finish, you always check for like terms. In this case, I do have some. Negative 15x and positive 2x. So I'm going to go ahead and write down 6x squared in the front. And then negative 15x plus 2x is going to give me negative 13x. And then I have minus 5 on the end. And this is already in standard form, so you're all good to go. Remember, standard form is ordering them from the biggest exponent down to the smallest exponent. So that's just a little sneak peek of double distribution. Okay, so we're going to move on to number 3, 3x minus y times 2x minus 5y. Now this one might look kind of scary because there's 2 variables this time, but really it's the same process. Again, the operation in between these parentheses is multiplication, okay? If it was plus, then I would add them. I would do what I did the day before. I would distribute and then combine like terms. But here we are multiplying. So you see that you have 2 terms in the front, so you got to make sure you double distribute both of them. So 3x times 2x. Well, 3x times 2x is 6x squared. 3 times 2 is 6. X times x is x squared. Then you have 3x times negative 5y. That is going to be negative 15, because 3 times negative 5 is 15. And then just xy. X times y. I can't combine those. They don't make anything fancy, so I just put them next to each other. Okay, and the next term is the negative y. So negative y times 2x. So I'm writing these arrows super carefully because I'm doing this intentionally. I'm not just writing the arrows to write the arrows. So negative y times 2x is going to be negative 2xy. Now I write xy, but you can write yx if you want. I just like to keep my things in alphabetical order. So this will be negative 2xy. The number always goes to the front of your variables, never in the middle. So you would never have negative y2x because you might mistake that 2 for an exponent, so you want to be super careful not to do that. Okay, and then we have negative y times negative 5y. That's going to give us positive 5y squared. So negative 5 times a negative is going to give us a positive, and then the y times the y gives us the y squared. Now we're almost done, but we have some like terms. Remember, like terms have the same variable, same exponent. So the 2 middle terms are like terms, negative 15xy and negative 2xy. These are like terms. They both have an xy, and they're matching exponents and everything. So we have our 6x squared at the front. We're going to combine the negative 15 and the negative 2. So negative 15xy minus 2xy is going to give us negative 17xy. And then we have positive 5y squared. Okay, moving on to number 4. Now I have a star here because this one looks a little bit different. So let's talk about what this means. I'm going to tell you not to do this, and you need to remember not to do this because every year about half the class does it, and they get it wrong, and the whole problem gets wrong if you do it this way. I promise you. Like, if you do this, you get no credit. You get no partial credit whatsoever. So sometimes when people see this exponent out here, their first instinct is to distribute. They want to distribute this. That is incorrect. I can prove it to you why it's incorrect. Okay? So I'm going to use real numbers, okay? I'm going to use real numbers here. 8 minus 5 squared, okay? And then before I show you that it's incorrect, let me show you the correct way to do this. What does it mean when something is squared? Like, what does x squared mean? It means I have x times x, right? I have 2 of them. So when I have something that's squared, I need to write it twice. So when you see a squared like that, you write it twice. This is super important. So you see that there's a square here, so you're going to write x minus 1, parentheses, x minus 1, parentheses. Because once you do that, then you can move on. So we're going to do it this way first, and then I'll tell you why the other way is incorrect with the real numbers. So x minus 1, parentheses, x minus 1. You write it 2 times because that square means 2, right? You write it twice. So once you write it twice, then you do double distribution like normal. So x times x, x squared. X times, well, I overshot that. X times negative 1 is negative 1x, or just negative x. Okay? And then the next thing I'm going to do is the second term, which is -1, so -1 times x is going to be negative x. -1 times -1 is +1. Okay, so what was the only difference from this problem to the previous problems? We had to do an extra step at the very beginning and write it twice. But after you write it twice, it's exactly the same. You just have to remember to write it twice because you're going to want to distribute that 2 and it will be wrong. And again, I'll prove it to you in 1 second. All right, now before we move on to proving it, we want to go ahead and combine any like terms that we have. So we have -x and -x. So we have x squared stays in the front, -x minus x. So I have -1 minus 1 is going to give me -2x, because those are going to combine to make -2. And then I have +1. Now I can't combine any like terms, so this is my final expression. So let's talk about this. I'm going to do it 2 different ways for you so I can show you the right way and the wrong way. 8 minus 5 squared. So on the blue side, I'm going to do it the correct way. Okay, the correct way is if you see it twice, you're going to write it 2 times. So I have 8 minus 5 times 8 minus 5. Okay, so nothing wrong here, right? That's what it means squared. So 8 minus 5 is 3, and then 8 minus 5 is 3. So 3 times 3 is 6. And I can actually type this into Desmos, and it will give me that number, right? So I'm going to go ahead and go to Desmos, if it will load. Put on projector mode so you can see better. Parentheses, 8 minus 5 parentheses squared. Oh, sorry. 3 times 3 is 9. Okay, that was my bad. I had a brain fart in that moment. 3 times 3 is 9, I promise. I'm just crazy and I'm a little tired. But 3 times 3 is 9. And as Desmos states, it is equal to 9. So let's do it the other way, and the wrong way. The wrong way is distributing the 2 in. If we distribute that 2 in and we square them, right? 8 squared, and then you do minus 5 squared, right? Well, 8 squared is 64. 5 squared is 25. I don't even know what that is. 64 minus 25. That's 39, right? So you clearly don't get the same answer in either case. So you got to figure out, hey, I have to remember if there is a 2 here, I must write it 2 times. You do not want to do it this way. You will get it wrong every single time. And if you do it that way, you will receive no partial credit. And I promise you, on a STAR test, if they ask you to do a problem like this, they will have an answer choice that is matching the wrong way to do it, because it always happens because students like to do that mistake. Okay, number 5, 4w plus 3 squared. Again, I see that there's a 2 here, so I'm going to be super careful and make sure I write that 2 times. So 4w plus 3 times 4w plus 3. And now I'm going to double distribute. So 4w times 4w. 4w times 4w is going to give me 16w squared. And then I have 4w times 3, and that's going to be 12w. Okay, so 4w times 4w is 16w squared. 4w times 3 is 12w. Okay, moving on. We have 3 times 4w. So we've single distributed, or we've distributed once, and now we're going to distribute the second time with the other term. So we have 3 times 4w, that's going to give us 12w. 3 times 3 is going to give us 9. I know 3 times 3 is 9 now, so I'm not crazy. I was like, what happened? I was a little worried with myself for a second. All right. So now, before we finish, we want to make sure and check to see if we have any like terms, and we do. We have w's that are similar, so 12w and 12w. So we have 16w squared. 12 plus 12 is 24, so positive 24w. And then plus 9. So this is our simplified expression. We cannot simplify it any further. Okay. And I'm going to make this a little bit smaller so I have room for number 7. There we go. Okay. Moving on to number 6, 5m minus 4 squared. So I want you to go ahead and try this one on your own so you can see if you can do it yourself. But remember, hopefully, that you notice that, hey, I have a 2 here, which means I need to write it twice because I want to be able to multiply these binomials, but I can't multiply them yet because, well, I don't have it expanded. So we want to expand this out real quick. So you're going to write it 2 times, 5m minus 4, parentheses, 5m minus 4. Okay? And then I can do double distribution. So remember, double distribution, you're distributing something twice. Or you're just distributing twice, not distributing something twice. Okay, So we have 5m times 5m, which is 25m squared. 5 times 5 is 25, m times m is m squared. 5m times negative 4 is negative 20m. And then we have negative 4 times 5m. Did I use red on this side? Oh, no, I didn't. Negative 4 times 5m is negative 20m. And then negative 4 times negative 4 is positive 16. Okay, now we're going to look for like terms, which we do have, negative 20 and negative 20. Now, these are not opposites. So sometimes when we have opposite signs, they'll cancel. So like positive 20 and negative 20 would cancel. But negative 20 and negative 20 do not cancel. They're not opposites. You would just combine them together. So I'm going to be super careful with that. Sometimes people want to cancel them. So 25m squared. And then negative 20 and negative 20 make negative 40m, because I put them in the calculator, negative 20 minus 20, I get negative 40. And then I have plus 16. And then that is my simplified expression, because I have no more like terms. And I am going to make this a little bit smaller, so I have room for number 8. Okay. Number 7, all right. So we have 5x minus 2 times 5x plus 2. Now this is a normal binomial times a binomial, so I would double distribute, right? So we call it double distribution because if you had only a single thing, you would distribute a single time. But because we have two terms in the first set of parentheses, you're going to have to distribute twice because there's two different terms in it. So I'm going to go ahead and start, okay? 5x times 5x is 25x squared. 5x times 2 is positive 10x. And then I'm looking for a color to use. And then we have negative 2 times 5x, which is going to give us negative 10x. And then negative 2 times positive 2 is going to be negative 4. All right, and as always, you check for like terms. In this case, we do. The x's are like positive 10x and negative 10x. So I'd have the 25x squared at the front. And then let's think about this. 10x minus 10x. If I have 10x, let's move that over here. If I have 10x and I subtract 10x from it, I have nothing left because 10 minus 10 is 0. So what happens to these two? These end up actually canceling each other. Now, why is that? Because they're opposites of each other. Positive 10 and negative 10 cancel each other out. Whereas in this case, we had negative 20 and negative 20. Those aren't opposites. In this case, we had positive 12 and positive 12. Those are not opposites. And I know that sounds silly to remind you, but people do make that mistake. They see the same number, so they cross them out. The only time they would cancel each other out is if they're the same number, but opposite signs. Okay. And then we just had the negative 4 left because that middle term got canceled. So here we'd actually only have 2 terms when we finish. Okay? So go ahead and try number 8 if you feel comfortable enough with it, and I suggest that you try it on your own, pause the video, do whatever you need to do, and then we will start. Okay, so I'm going to go ahead and begin. So I see that I have 2 sets of parentheses here. I see that the operation in between is multiplication, so I'm going to multiply by double distribution. So z times z is going to give me z squared. Z times positive 6 is going to give me positive 6c. And then I'm going to do what color here? It's always a tough decision for me. I don't want to do pink. I feel like I've done pink a lot. Maybe purple? Okay. Negative 6z, negative 6 times z is negative 6z. And then negative 6 times positive 6 is negative 36. Okay, so I've double distributed, and now I'm I'm trying to move this so it's lower. Okay, and now I'm going to check for any like terms, which I do have, positive 6z and negative 6z. So my first term is going to be z squared. And then that middle term, 6z minus 6z. 6 minus 6 is 0. These cancel each other out because they're the same number but opposite signs, so I don't have that term anymore. And then I have minus 36 for my second term. So in this case, I have 2 terms as well because that middle term got canceled. That doesn't always happen though, right? Because in a lot of our examples, we have a trinomial when we finish, right? We have a trinomial each time. But sometimes if that middle term cancels, you end up with a binomial, which is 2 terms. All right, moving on to number 9. Now this one is a little bit different. It looks a little bit different, right? And here's why it looks different. This first set is a binomial, but here we have a trinomial. So does it change the way we do the math? No. You're still going to double distribute. You just have one extra term to distribute it to. So instead of distributing this x 2 times, you're going to have to distribute it 3 times to all 3 terms. So x times 3x squared. Now, x times 3x squared is going to give us 3x cubed because we have an extra x being put into there being multiplied. And then we have x times 5x, which is going to be positive 5x squared. The most common mistake is that the people don't combine the x's together. You want to make sure you don't skip on those x's. So x times 5x is 5x squared. And then we got to distribute the x one more time because there's another term in there instead of just 2. We have 3 terms in the second parentheses, so you make sure you distribute it to everything. X times negative 1 is negative 1x. Whoops, sorry about that. Okay, now we are almost done, but not quite. So you want to make sure you distribute everything. So you distributed the x to every term in the second set of parentheses, so you're good there. So now we're going to do the same thing with the 4. 4 times 3x squared is going to be positive 12x squared. 4 times 5x is going to be positive 20x. And then I think I might have made this a little too low. And then 4 times negative 1 is going to be negative 4. There we go. Oops. Man, I'm struggling today. All right, now there's way more terms this time, but you always want to start with like terms if you have any like terms. But again, I always have to start with the highest exponent. So I noticed that my 3x cubed doesn't have any like terms, right? So this term in the front doesn't have any like terms, so I leave it as is. Well, I have one set of like terms over here, 5x squared and 12x squared. Well, 5x squared and 12x squared are going to make 17x squared because I'm combining those like terms. But then I have another set of like terms. You want to be super careful and check for those like terms. You have negative x and positive 20x. Well, negative 1 plus 20 is going to be positive 19. So you have positive 19x there. And then that 4 on the end doesn't have any like terms, so you're going to leave it as is. So you are now finished with this expression because you no longer have any like terms. So what was different about number 9 compared to the rest? There was just a little bit more multiplication that you had to do because you had that extra term, but also you had an extra like term in the end. So instead of just having one set of like terms, we had 2 sets of like terms. All right, now number 10 is super important, so you want to make sure you're super aware on how to do number 10. Okay, so Jamie is building a rectangular patio with dimensions 5x minus 1 and 6x plus 2. Find the area of the patio. So I'm going to draw a rectangular patio because it's a rectangular patio. And anytime there's a picture or like they're asking me to find the area perimeter, I like to draw pictures so I can visualize it. So draw a rectangle here for you. Okay, so this is our rectangular patio. It says the dimensions are 5x minus 1 and 6x plus 2. So that means one side length is 5x minus 1 and the other side length is 6x plus 2. So I'm going to go ahead and put 5x minus 1 here and 6x plus 2 here. It doesn't really matter because in the end, you can flip-flop them and you'll get the same answer. So it says find the area. Find the area. Well, how do I find the area of a rectangle? To find the area of a rectangle, you would do length times width. Length times width. Well, do we know the length and width of this rectangle? Do we know it? Yes, they gave us the dimensions. Remember, dimensions are the lengths of the sides. So they gave us both side lengths of the rectangular patio. So we're going to multiply the length times the width. So you want to multiply 5x minus 1 times 6x plus 2. Okay, it is super important that you put parentheses here. Like, super important, because if you forget, you're not going to get the right answer. Because this is what people do. They do 5x minus 1 times 6x plus 2. They do this, and then the only thing they end up multiplying is these two. Okay, that's not how we multiply binomials with each other, right? So when we have binomials like this, remember binomials 2 terms. We have a binomial and a binomial being multiplied together. You want to make sure you put parentheses so that you do this correctly. So let's start over, right? We have a rectangle that gives us the length and the width. We're asked to find the area. To find the area of a rectangle, you do length times width. So that is why I have 5x minus 1 being multiplied to 6x plus 2. Remember, parentheses mean multiplication, so I don't have to write a multiplication sign in between. I know they're being multiplied. So we're going to go ahead and multiply these out. So we have 5x times, and I'm going to move this down. We have 5x times 6x. That's going to give us 30x squared. And then 5x times 2 is going to be positive 10x. Okay? And then I have negative 1 times 6x. Did I use red yet at all? Oh, I'm going to use red. Okay. I have negative 1 times 6x, which is going to be negative 6x. And then negative 1 times 2, which is going to be negative 2. Now we're almost done, but we are not, because we got to always check for like terms. In this case, I do have like terms, positive 10x and negative 6x. So I start with my highest exponent, which is the x squared in the front, 30. X squared is going to be the first term. And then I'm going to combine my like terms, 10x and negative 6, and that's going to give me positive 4x. And then I just have the negative 2 tacked onto the back. Now, can I simplify anything here? No, we don't have any like terms, so we're finished. This is the area of the rectangular patio. Now, oh geez, what's going on with my iPad? Sorry, give me 1 second. Now, the most common mistake I see is the first thing I mentioned, right? If you forget the parentheses and they just put a dot in the middle with the multiplication sign. That is incorrect. Something that is also incorrect is when someone tells me that the area is like 5. Like, how did you even get a real number, right? Because your area and your width and your length have letters in them. They have variables. So your answer should probably have variables in them. So you want to be super careful that you're not getting fooled by, oh, I need to get like perfect numbers out of this. You do not, right? That's not the goal of every single algebra problem, to get like a pretty number, because we know that we don't always get a pretty number. So number 10 is super important. Make sure you know how to find the area of a rectangle, know the formula for the area. But if you don't have any questions, or if you have questions, go ahead and feel free